Hello, everyone. Thank you for having me. Today, I will be talking, as Shana said, about few tips on modeling things in Scala. Just a few seconds about me. I'm working with Scala for like 5 years, so it gave me a little bit of experience. I was working commercially slightly longer, which is for ideas, but I'm like tackling a lot of programming things for like 16 years. But obviously in this industry, it doesn't mean much if it isn't on production. Other than that, I'm also blogging at my blog kubuszok.com. Maybe some of you found it at some point. And I also released some niche book about Scala and JVM that hopefully a few people might find useful. But today we will be talking a little bit about modeling. So what I wanted to start is about case classes, which we all know and love, but sometimes we abuse them or not use them well enough. Fields for improvement. For instance, we could also not use flat case classes. So we talk a little bit about how modeling nested case classes, or basically nested models, might help us. We will also talk a little bit how sealed traits could help us express our domain, and that sealed traits aren't only about using enums for enumerations. Finally, we will also talk a little bit about how the same model might not necessarily works for everything, from the front end to database. That sometimes splitting things and using the strengths of each of the parts of our applications to their fullest require us to use simply different models. And if we have enough time, we will also talk a little bit about how we can help us basically working with some integrations from different libraries that usually requires of us to use a lot of imports. And if we forget some of them, then some derivation might fail, or some functionality is not available. Well, quite often we could make our life easier if we just devise some utilities. So let's start with case classes. As a warm-up, we might talk a bit what we will obtain if we simply use a case class. Like this very simple case class is made of two things, and what is happening underneath if we implement such thing? Well, under the hood, it will be turned into this this normal class, which also implements several interfaces. We will for free receive equals and hashcode method properly implemented so that we can safely compare two different values, and we don't have to worry about that. Our intent will be misrepresented. If the content of two case classes is the same, then the case classes are considered the same. This is something that we basically expecting of values. We will also have this nice utility of the string overridden, so that it will print us some nice things for instance, debugging or logging. We will also have this nice copy method. So creating a new value is not something that we will have to struggle with. It's just simply generated by the language. And also, we will have this nice little companion object generated, which will provide apply and unapply. And those two functions have this nice property that when you look at the code that you generated with them, it looks very symmetric. Like when you look at this, when you look at this pattern matching, you can see that how you build this value is symmetric to how you extract values from inside pattern matching. So this is really nice. The fact that we can compare values is also really nice. One of those less known properties of those case classes that we sometimes overlook and sometimes not understand is this part about object extending function. If we do not write anything like our own custom companion objects, this will be generated for us so that this companion will be implementing the function interface. So this is why if we are working with, for instance, Slick, we could take a look at, you could use method like tupled, but the moment we are trying to implement our own applies or some customizations, we suddenly realize that we have to use at expansion, and then we would be able to call the tupled on it. So when we have those case classes, we probably should expect that they are working in some predictable way. And for many people, predictable would boil down to two things. For first, we want to represent some value or record. So basically, if anything inside the case class is different, then two instances of case class can be considered equal, even if just one thing is different. Other is that basically it's some representation, probably some representation record, I don't know, from database or something that people generally understand as pack of value that should be always considered together, and it always has the only properties of this pack of data is derived from the data inside it. So there is no external life cycle, there is no ID, there is nothing that we would need to know outside of anything that is inside this object itself. And the other requirements that we would have to have is that all the properties of this case class would also have to be some value type or something that we could consider value. Otherwise, we might be shocked. So let's take a look at what happens when we do not follow those two of these principles, which we sometimes do, and we aren't even aware of that. So sometimes people put state inside a case class. It seems like easy thing to do. It's just because we're gonna use apply anyway. We're gonna use toString anyway. So why not? This way we can use this nice little syntax without calling new. Except when we have things like that, when we have any sort of like mutability inside our case or values, not only case classes, but like any sort of things that is marketed as a value, we might end up with a situation like this. So we create a counter, we put this counter into some nice little set because we want to, I don't know, trace things inside Prometheus, and we would like to model things using a separate counters, each with its own name. And then we model them using case classes because why not? And then we might discover that even though we put some counter inside of our set of counters, the moment we call some side effecting action, this counter disappears from the set. And this is because basically one of the values that makes this case class change, the counter, and this counter is both used for the quality check as well as for hash code generation. So in case of those hash sets, suddenly we use a different hash to put value inside and to like basically check if the value is inside the set, and different value is returned when we are calling this counter now. So those are those things that could catch us by surprise in production if we simply think that, oh, well, putting mutability inside case class is not a big deal. Apparently it might be. And even if we decided to just move this var inside this case class definition so that it wouldn't be reflected into string and comparison and copy, we still might have this issue that, okay, so those two instances of named counter would be compared by the name, but we could have like two different counters and that would be considered the same because they have the same name, but they could be have different counter values because they would be appearing in different contexts. So in such a situation as we see here, usually it would be better to just create a normal class and keep the name as some sort of property and not misguide anyone into thinking that this piece of code should be considered an actual data type. I mean, like actual value type, which all of its worth is lying in its public values, and all the properties of the object could be derived like exactly out of it. Another instance I saw on production is when people were putting side effects into case classes. Like for instance, we might decide that you could use case class for storing DB connection because why not? Like we could compare two different DB connections if they're using the same URL and the same user and the same password, and basically it's the same, even though in practice, internally there might be some interesting things happening, and probably we wouldn't like those interesting things to happen inside something we consider pure dump data. So like in this example, probably it would be good for us if we like decoupled it into two different things, one which is like purely about data and the other which is purely about behavior. And this way we could like clearly see that, okay, one of them we can easily mock and pass and recreate from scratch and nothing changes. And the other one, well, internally it might doing everything. It might connect to the database, it might disconnect, reconnect, it might store some states inside vars or mutable data structure. We don't know. We cannot expect anything based on the very like definition that this is a class. But at least we wouldn't be surprised if something like that happened. While if we put things into case class, it would be surprising. And I saw these things happening in production because people wanted to spare themselves from writing new, and case class generates apply. So just put case class on everything because it's nice to not have to write new everywhere. So just please believe me, it's not a compelling reason to make something in that case class. And the last example is sometimes we might miss that something is not a value, or it wouldn't be treated as a value by JVM. Like, let's say we are working in some security domain when we have to work with public and private keys. And security guidelines for Java usually says that we should use RIs for handling such things because RIs can be nulled when the passwords stop being used. And it can be also displayed inside the logs because RIs don't have some pretty prints for logging. But the thing is that RIs also don't have any built-in utilities to comparing them with each other. So even if we had two arrays with the very same content, if we try to compare these arrays, then we will be actually comparing their references. Same with the hash code. So such a case class would be broken by design if we basically use this design. So if we are working with such a data, we want to put them inside a case class, then usually we need to use some sort of wrapper which would actually make it like a value. For instance, here we can have RISEC, which will provide us some sane printing. Not sure if it's a good thing to be able to print things in this case, but at least behavior would be predictable and we would be able to compare those two values with some another key pair and check if, okay, if the public and private key are actually equal, even though the RIs underneath might be of different references. And this also might affect how we might use cats type classes when it comes to using those, when we're deriving them out of our case classes. Like one of my private recommendations, so please take it with a grain of salt, is that equals should match behavior of equals. This is why, because even if you try to use cats ecosystem to the fullest, and when you try to compare values inside containers using, for instance, contains underscore, so that it would use eq type class, or even if you try to use triple equals instead of double equals, still at some point you will probably pass your class into something that wasn't built with type class ecosystem in mind, and then you might be surprised that even though the part of the code that you are like personally responsible is like working perfectly okay, as soon as you pass things into, let's say, normal Java's built-in set, it starts using built-in functions like equals and hash code. So you simply making sure that they are compatible with what we're using with AQ makes your life easier. If you want to override the behavior, just do this explicitly, but make sure that the default instances will be compatible with what case class is doing even without them. So it might be like, you might treat it as some sort of like type-safe alternative, which in some cases might be even an optimization, but just don't treat it as a separate behavior. And another things that I would recommend is to not use show for any sort of business logic. It's very good for debugging, especially if you like use things like show pretty, and if you put some customized logic to make this show pretty works even better than what is done in kittens. But be very careful not to rely on this show for parsing something, generating some code. It's better to just put it into like separate utilities, otherwise you might be surprised and hurt yourself. And same for toString method from basically everything. Just use it for the debugging, but never use it for anything serious. And another topic I want to discuss is usage of the flat case class and like nested case class when we have nested models. So quite often you could see that in the code bases that when you're using any sort of like entities modeling or values or events or whatever, case classes will be flat. We might discuss later on why people might do this, but usually that's the thing you will see. You see it in tutorials, so people are following that, and those are the kind of entities that you are working with. So when you try to use it, the comparison, it's okay as long as you want to compare the whole version of your data. Like if we treat it as some user entity, then if we are comparing this entity as a whole, basically we are checking both if it's the same entity, and if it's the same entity in the same moment in time, because entities by definitions might evolve, they might have life cycle. And if we simply use equals, then we won't be able to detect if this is a case of the same entity, but from different time periods. Only if this is like exactly the same thing from exactly the same moment in time. So if we wanted to compare ID, well, in this case, it's relatively easy. We just need to get the ID out of the entity and it works. But what if we wanted to, for instance, check that all the address lines are the same, that address line 1 and address line 2 and seat and zip code is the same if we wanted to check if two user addresses are the same, for instance, because two users are shipping to the same place. So in that case, we would have to compare all of these fields one by one. And if it happens very often, we might see that actually address here is a separate model that should have its own, should live on its own, probably used by this bigger model, but it might be easier for us in the long run in the domain code to treat it as a separate model, a separate thing. So, and this would be getting even more disastrous when it comes to those data that you usually see in Spark when you have flat record data, which has something like 30 or 40 or maybe even 50 columns. So in that case, in these cases, it's like even harder to like figure out what is what. But hopefully in our normal code, we don't like end up with those cases, especially if we don't want to, because like in this example, we could see that, okay, we just extracted thing to a separate model. We made it so that user address is split into its ID and data, so we can compare things like separately. When it comes to derivation, it also will be handled because Scala handled derivation handles those kind of nested cases. You want to simply use it. Then when we take a look at the code, the comparison, it's pretty obvious. Like from looking for the code, we're seeing if we're comparing user in the same moment in time, if we are comparing ID, if we are comparing if two different users might have the same data, or if two users might have the same addresses. And basically, we don't have to like comment things or refactor things when we or trace all the places that we use. We might checking for address in our code base, because just by splitting this bigger type into small types, we like already forced our code base to have a better, like, more self-evident model, self-explaining model. So we might wonder why people don't go into nesting. I believe some people just never noticed that they wanted nesting. Probably some people didn't want to do nest cases because they are integrating with database or Spark or some external sources. But I believe there's also a lot of people who avoid it because of copying. Because when you want to update some model deep inside of your model, then you have to do this a lot of copies with nested data. Except this isn't necessarily true, because for a while we already have like quick glances, and you don't have to read anything about optics theory, profunctors, anything like that. You just doing one simple import, and then you are doing this using this nice little DSL that is IDE friendly, and the library takes everything in its own hands and do things for you, compiling it into some macros, which will create a new model like really easily, and you don't have to think about it. So you can simply express, okay, I just want to update this nested field and call it a day. So let's go to seal traits. Why we might use seal traits in the first place? So the obvious use case would be enums. We have some limited set of values. We use seal traits and case objects. We should avoid enumerations. And then we are able to pattern match on it, and this pattern matching is exhaustive. So with Scala enumerations, it won't work this nice, but if we simply use seal traits and case objects, it will work quite nicely. And if we're missing some useful utilities like the list of our possible values, we can always use enumeratum. But it isn't the only use case for those seal traits in our code bases. Like any sort of like limited numbers of valid combination is useful to us. Like let's say we have email, and this user email represents email lifecycle. So when we create the email, we have some email in our database, but we don't know if it's confirmed. When user confirms it using some sort of like link or whatever, we know that this email is confirmed. But then user might want to change his email, and now we have two emails, because until user confirmed this new email, we should consider that, okay, maybe it was a mistake and maybe they want to still use the old email. So in such a case, we probably shouldn't like break our behavior and replace the email, and then user cannot for instance log in because they didn't confirm their new email, and the old email already stopped working. So we have this pretty non-obvious on the first glance data structure, and this is probably how we would store things in the database, but it doesn't necessarily mean that we should be using it inside our code base, because it's not very descriptive. And instead, we might just simply model this as 3 distinct cases. We might see that if the email is new and unconfirmed, we're just storing this field name email, so that we could use it to, for instance, sending a confirmation email. If it's confirmed, that we have a separate case telling us explicitly, okay, that's user already confirmed this email. We can use it to whatever purposes are restricted only to users with confirmed emails. And if user is changing their email, then we can see the old email and new email, and we know that the old email is confirmed, the new one not necessarily, because it's a separate use case. And how we were like storing it inside database or whatever else is irrelevant. We can just do the mapping later on. And this particular case would be even nicer like in Dotty, because this new enum keyword, which would make things like even simpler for us to write. But what we can do if we cannot for some reason use enumerations, like if we had 3 fields and they generated, let's say, 1,000 possible cases, and we wanted to support 900 of them, then probably writing down 900 enums would be a very good option for us. Maybe we could limit it with some clever splitting of the cases into something useful, but still, even if we had like 100 use cases, then probably it wouldn't make sense to maintain 100 enums and writing pattern match on them. So in such case, it might be better for us if we use like smart constructors. So basically, we're making enable for the user to construct data on their own. they have to parse some raw data that we could validate, and if they pass our validation logic, whatever it is, we create this value for them. If it's not valid, we're returning some error. So this particular pattern, it's a little bit convoluted. Here we are using abstract to prevent generating copy method and apply method. We are putting sealed so that user cannot extend this class and then instantiate it. We are also using private so that the new constructor would be called. But this way we are basically prevent user from being able to create this instance outside of this class or its companion object. From what I see, there's like relatively little need for using such things. Usually either enums works pretty well, like sealed traits, or you can use things like anyvals or newtypes or indoti opaque types to implement similar logic, especially if you combine any sort of new type with refined. Then a lot of use cases that we used to use to prevent people from creating new instances, right now we don't have to do this. Like if we have like a single value and we just want to check some regex or if values within some range, we can already use refined. So this is like a very rarely used pattern, but it's worth knowing that if everything else fails, we can resort to it. And another part of my presentation that I wanted to focus is basically not using uniform modeling. This is also something that I see very often, and this is something that is very detrimental to any sort of modeling and expression parts or models, and basically it makes your life much harder than it should be, even though on the first glance it seems as if it makes your life easier. So what is uniform modeling in the first place? This is the idea that you have some model, you design it once, and you can use it for your business logic and for persistence and for API. So usually something that like you see in, for instance, Ruby or Rails, I guess also in Django, probably also you might also see sometimes somewhere in Spring Boot or things like that. If someone is a fan of that. So basically in a lot of rapid application development frameworks. And from my experience, when it comes to models that are like very rich have very rich domain and have a very rich behavior, and it's not only about putting JSONs into tables. It works something like this, that we start with a database design. So we are like starting with database driven design. Once we have a database table, we basically write some case classes that directly represent these tables, and then we are trying to forcefully create some JSON codecs or protobufs or whatever we're using to transmit data to match these models, which sometimes is very hard and usually completely unnecessary. And when we try to define any sort of like domain behaviors, we have the issue that suddenly any sort of domain operation we have has to be expressed in terms of basically working around some either single database rows represented as case classes or as some collections of these database rows represented as case classes, which is well, very poor way to define your domain. And alternatively, you can do the same thing, but starting with the API. So you design your JSONs, and then you try to somehow fit how you store things in database to how you design your JSONs. So neither of the approaches work really well, even though people, and despite that, people are still using it in a lot of places because apparently they never thought about trying anything else. So an example of how it usually works and what I don't like is that we are starting with the database. For instance, if you wanted to store users and addresses in the database, so if we have users and addresses, it's obvious that they should be different tables, which means that obviously we would have two different entities, user and address, both with their own IDs and values, and obviously normally they are flat because that's the easiest way to read things from the Doobie or Slick or whatever database we are using, because this way either we only have to use some tupled and unapply method when it comes to Slick, or things are automatically derived using Doobie, because this is like a very simple row with very simple values, and the Doobie derivation works perfectly fine with it. And if we wanted to have some more complex models, then either Doobie and Slick would have problems, or we would have to do some extra mapping, and people usually get lost when they try to do this, so nobody ever attempts. But once we have these models, then we try to use them for everything, then we will also have to use them for JSONs. And then we have this tiny little issues that perhaps business require us to have these JSONs be slightly different than what we try to store in our models. So suddenly we have a lot of Stack Overflow questions where people are asking about how to write their own codec using some JSON cursors. And when they're writing encoders, that they are asking about how to build their own JSON ADT, and how are JSON's internal models working, because they need to implement a very simple thing. Even though if you take a look at, actually they don't really need it. They just use separate case classes for their models. They would have them derived automatically with any sort of customization on their own. And obviously, the biggest issue is that your model design is now struggling with your model using everywhere those very dumb models where you have to manually work around about the fact that your model doesn't have some internal self-awareness, and that your whole logic is basically about gluing together a lot of intermediate functions to get the desired result, and then persist it when the persistent layer is like really thin and really obvious, and when the actual domain logic is super complicated and you could easily get lost and produce some bugs. So what would happen if we have a separate models for each of those things? For instance, we might start by designing the model that the best represent what we know about our domain. For instance, we might learn that, okay, address and email, they're always part of user, and we actually consider user some sort of like aggregate and treat everything as a part of a user's lifecycle, whether it's about email changing or address changing or adding email address or whatever. Address would be like a separate value. User's email would be also like a separate value, which would internally encapsulate what it actually is. So if we had something like that, obviously it would be very difficult to shove this directly to the database or fetch it, or probably it wouldn't also be very nice to return to user as a JSON, which perhaps shouldn't know user's email or all the user's addresses or all the details. So probably this is not something that you should return to user directly. But this is also not a problem, because we can create a separate models, which are the best way to design things and how we store them in the database or JSON. Like here, for example, if I want to store an address, I could actually have an address database. It's just our model doesn't have to know that we are using some address table underneath, and that it has some sort of like layout and things. It's like completely unrelated. It's also in domain-driven design. Usually, it's called being persistent agnostic. Like how you use your models shouldn't tell you anything about how they are being stored inside databases or how they are being sent through JSONs or protobufs or things like that. So you can encapsulate this knowledge in those separate models that you could map to and from, and in that mapping actually perform some sort of validations if this data obtained from the external world could be treated as or converted to some valid models inside your domain. And this is where you might perform this check on your boundary context. Here for the user, we did the same thing as for the address. We have a separate data transfer object. And since we have a separate data transfer object, we can basically create it from our normal model using this nice little helper we write for ourselves. And suddenly all the operations that we usually do, well, they might be a little bit more complex, as we can see, because suddenly we are abstracting like user as a whole. We don't treat it as a pack of completely unrelated tables, which are only connected through some reference by in referencing inside Postgres or something like that. But since we put that logic in this one single place, we also don't have to worry about it everywhere else. This logic about querying. So if the absurd and fetching, we put all the complex logic about them in only a single place, then suddenly working with our domain becomes like really pleasant. Like if I wanted to append some new address to the list of the addresses the user using, and said that okay, primary address is always as ahead of the list of addresses. So right now it's only about working with a simple Scala data structure. We can simply like look inside of it. If the address is somewhere there, we like removing it and putting it on the front, which is like much easier to understand. Like as a programmer, it would be much easier for me to understand what is happening if I see something like that, as opposed if the logic was hidden somewhere inside this nasty logic where I have to explicitly work with all these database rows represented directly as models, which tells nothing about the relationship between each other. So
sorry, I'm going to have to interrupt. I'm going to have to wrap up your talk soon, just to let you know. Just we've only got like another minute left. Sorry to rush you along.
Okay. Yeah. So just finish. Okay. So as you can see, even though we paid some initial cost about introducing those models and having those mappings like on the edges, when we started working on it, things got much smoother. And unfortunately, I cannot say too much because we are running out of time. So I can only say that if we have a lot of imports and we have to repeat them everywhere else, then basically we can usually cats or its ecosystem allows us to shovel all of that imports inside a single object to import, because a lot of these imports are usually very friendly to this kind of approach. Tapir also has a nice example on its documentation page. And also if you are struggling with importing all the same things everywhere, like cats syntax, then you could get away since Scala 2.13 with just using some nice compiler option, which lets you import all these things in one go. You just have to remember that you are not appending things, you are defining all the things that will have to be always imported. So things that are imported by default, you have to add them yourself. You don't want to lose it. So yeah, that's all I wanted to say for today. So